This is Mr. Beck Does Your Homework. This is AP Physics, Homework 12.2, question number 9. It says, a soap bubble with index of refraction 1.33 is floating in air. If the thickness of the bubble wall is 102 nanometers, what is the wavelength of the visible light that is most strongly reflected? Answer in nanometers. So, in this situation, you have the wall of the soap bubble here. So this is just part of that big whole sphere of soap. On the outside, you've got light hitting. That light hits the soap bubble and goes inside, and some of it continues on through back into the air inside the soap bubble. So this is air, and this is soap bubble. Of course, some reflects off of this surface, some reflects off of this surface and is transmitted there. And so we have to worry about whether these are going to be reflected or not. And I'm looking for the wavelength that is most strongly reflected. So I'm looking for a yes, it is reflected. So the first thing I need to know is that this has an n equal to 1. The soap bubble has an n equal to 1.33. And this air inside again has n equal 1. So I'm going to get a light to heavy reflection on the opposite side here. But here, heavy to light, it's going to reflect on the same side. So there's going to be no flipping here, but there is going to be a flipping here. So I'm going to need a certain amount of wavelengths in order that this and this are going to be strongly reflected, so they're going to be in phase. The way I remember that is with the phrase in order, no quarter. So are these in order or out of order? It looks like they're out of order to me. So if it's in order, no quarter, then I can refer to this table. In order, no, if it's in order, yes, then I'll have no quarter reflecting. So what I'm looking for is it's out of order, because it's not in order, so it's out of order. And do I want it to reflect? Yes. Well, 1/4 wavelength will reflect if it's out of order. These are out of order. I want it to reflect, so I need a 1/4 wavelength. So I'm using this in order, no quarter table to figure out that I need a 1/4 wavelength in order for it to reflect strongly. So I know the wall has a thickness of 102 nanometers. So 102 times 10 to the minus 9th meters is 1/4 of a wavelength. Okay, so is lambda over 4. And that's the wavelength within the substance, so I'm going to call that lambda 2. So what I can do is multiply this 102 times 10 to the minus 9th, 102 nanometers by 4. That'll give me the wavelength in the substance, but I got to find the wavelength out here or in here. So now I can apply N1 lambda 1 equals N2 lambda 2 in order to plug in this lambda that I get over here with the N2, which is 1.33, and then N1 is going to be 1, and I'm looking for lambda 1. And that should give me the answer. It says answer in units of nanometers, so whatever I get, if it says something times 10 to the minus 9, then that'll be the number. The other way is to just multiply by 10 to the 9th, and I'll get how many nanometers of light I'm looking for.